Is hybridization of nitrogen. Nitrogen atomic number 7. Its electronic configuration is 1s2, 2s2, 2px, 2py, 2pz. This 1s belongs to first shell. This 2s, 2px, 2py, 2pz belong to the second shell. This nitrogen contains two shells in its structure, first and second. Second is the last one. Second is the valence shell. In valence shell it contains 2, 3, 4, 5 electrons. Okay, so this nitrogen also undergoes sp3, sp2 and sp hybridization. Okay, in sp3 hybridization, just like carbon also shows sp3, sp2 and sp hybridization. When this s and p 3p orbitals mix together to form four equivalent hybrid orbitals, this 2s and these three 2p orbitals will mix together to form four sp3 hybrid orbitals, sp3, sp3, sp3 and this one sp3. Okay, these mix together to form four equivalent hybrid orbitals. One of these sp3 hybrid orbital contains 2 electrons and other 3 contain 1, 1 and 1 electron each. The 4 sp3 hybrid orbitals of nitrogen are directed towards the corner of regular tetrahedron structure. Tetrahedral structure is just like this one, center nitrogen, 1, 2, 3 and 4 atoms. If nitrogen is arranged in 4 directions, it shows the tetrahedral arrangement. One of this tetrahedron position carries the lone pair of electron and other 1, 1, 1 electron. The 4 sp3 hybrids of nitrogen are directed towards the 4 corners of regular tetrahedron, just as sp3 hybrid orbitals of carbon do. So consider the formation of methylamine. Methylamine CH3NH2. In methylamine, both nitrogen and carbon. Its structure, if we show its open structure, CH3, CH3, NH2, NH2. This nitrogen is arranged in 4 different directions in octahedral arrangement, and carbon is also attached with 4 bonds. This also shows sp3 hybridization. In this example, both nitrogen and carbon show sp3 hybridization, sp3 hybrid orbitals of carbon and sp3 hybrid orbital of nitrogen. Okay, in C and bond, sigma bond is formed by the linear overlap. Okay, hybrid orbitals will show carbon, its ground state electronic configuration is 1s2, 2s2, 2px, 2py, 2pz, 2 to 4, 5 and 6. Outermost shell contains 2s, 2px, 2py, 2pz orbitals. One of these electron from low energy orbital is jumped into high energy orbital 2pz, that is empty. After excitation of one electron, it contains 1 and this one also 1 electron. Now total there are 4 unpaired electrons in the excited state of carbon. Okay, these 4 1s and 3p atomic orbitals of carbon also mix together to form 4 sp3 hybrid orbitals of carbon. So just like this arrangement, carbon 1, 2, 3 and 4, 4 hybrid orbitals, 1, 2, 3 and 4th on the back side. This backside orbital arrangement or bond is shown in the dotted line. Okay, In carbon, each hybrid orbital contains one electron. One, 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 and this one also one electron. And nitrogen, this also has 4 sp3 hybrid orbitals. One of them contains 2 electrons. Okay, and other 3 sp3 hybrid orbitals are arranged and this will show linear overlap forming the sigma bond. In nitrogen, one sp3 hybrid orbital contains lone pair of electron and other one and one electron. In carbon all the sp3 hybrid orbitals contain one electron each. So sp3 hybrid orbital of carbon, there are 4 sp3 hybrid orbitals of carbon and also 4 sp3 hybrid orbitals of nitrogen. This one also sp3 and sp3. These will overlap with the 1s orbital of hydrogen 1s orbital 1s orbital of hydrogen sp3 of nitrogen and sp3 orbital of sp3 hybrid orbital of carbon will linearly overlap and form sigma bond. Just like this. And carbon from this side is bonded with the hydrogen. Carbon is bonded with 3 hydrogen atoms by sp3 s overlap. S orbital of hydrogen also contains one electron and one electron. So in this structure, H sigma bond is formed by the overlap of sp3 orbital of carbon and s orbital of hydrogen. All the bond angles are approximately tetrahedral. All the bond angles are 109.5 degree. HCH bond angle. HCH bond angle is 109.5 degree. H and H bond angle H and H bond angle is 105.9 degree, that is less than the normal tetrahedron angle, that is 109.5 degree. Why? Just because of this lone pair of electron. This lone pair of electron compresses this bond angles, that's why its bond angle becomes shortened. Okay, the angle between sigma bond in this side are compressed. The bond angles between sigma bond on the other side are